Welcome back. In this video, we're going to work on section 5.2, which is about solving systems of linear equations, this time using the elimination method. We saw in the last section that you can solve a system of linear equations by graphing, but we also saw that that was kind of a pain because, well, you have to take the time to graph two lines, and the accuracy of your answer depends on how good your drawing is. And that is always that fun. And so I want to have a better, more practical method of getting this done. That's where substitution comes in. Of course, the method of graphing is useful if you want to understand the concept and or visualize the solutions that you're getting. So always keep that in mind, but realistically, you're going to want to not use graphing most of the time. All right, so the second method that we're doing is substitution, and based on the name, a substitution sounds like we're trading one thing for another, and that's really what we're doing. So taking a look at this system, we have negative 2x plus y equals negative 11, and x plus 3y equals 9. What we're going to do is we're going to take the second equation and solve it for x. X is equal to minus 3y plus 9. So we have solved the second equation for x, that is rewritten it so that the x is all by itself and there's no x's on the other side. And what we're going to do now is rewrite our first equation, which was negative 2x plus y equals negative 11. And where we see an x, that equation, we're going to replace it by the minus 3y plus 9. So it said negative 2x plus y equals negative 11. And here's where the substitution comes in. Where there was an x before in the first equation, we're going to replace that x by negative 3y plus 9. This gives us an equation that has only one variable in it. So that's good, and we know how to solve those. So let me do that. So we'll distribute to remove parentheses. That will be 6y, and then that's minus 18 plus y, that's negative 11. So combining like terms, 6y and y is 7y. 7y minus 18 is negative 11. We'll add 18 to both sides to get 7y is equal to 7. And that means that y is 1. Okay, once you know that y is 1, okay, this equation tells us how to get x if we know y. So x is negative 3 times y plus 9. That'll be negative 3 plus 9, or 6. Okay, so then our solution works out to be, well, x was 6 and y was 1. Our solution is 6, 1. Okay, and that's how the substitution method works. So here I did want to point out that the choice of that second variable, x plus 3y equals 9, that wasn't the only way that we could have done this. We could have taken the first equation. Let's at least start this one. The first equation was minus 2x plus y equals negative 11. If we had solved that for y, let me keep the y's on the left side. Keep the first equation and keep the y on the left side. Y will equal 2x minus 11. And then we can substitute that into the second equation for y. X plus 3y equals 9. Now we're replacing the y by 2x minus 11. So we have x plus 6x minus 33 equals 9. 7x minus 33 is 9. 7x is 42. And so that x is 6. Once you know x is 6, you can find y. Y will be 2 times 6 minus 11. That's 12 minus 11, or 1. And so we get the same answer. So this problem wasn't that much work. Okay, I did it twice. We did it one way, where I took the second equation and solved for x, and then I did it over again, where I took the first equation and solved it for y. So that was just to illustrate that you can work with either equation and either variable. Okay, and that's up to you. Sometimes there's an easy, obvious choice, and other times there's not. In this second example, it's pretty clear because the second equation is already solved for y. It makes most sense to just take and substitute that y in for the y that is in the first equation. We have x plus y equals 6, and y is 3x minus 2. According to the second equation, this gives, sorry about that, Zoom crash once again. 4x minus 2 is 6. 4x equals 8, so that x is 2. Okay, once we've got the value for x, we can substitute that into either of the equations, really. We'll take the one where it's easiest, 3x minus 2. So y is 3x minus 2. That's 6 minus 2, or 4. So when x is 2, y is 4. Make sure that you put the x on the x side and the y on the y side, by the way. And the answer here is not 4, 2. It's 2, 4. So make sure you get those in order. Okay, again, with this one, it was pretty clear. The second equation was already solved for y, so that was the obvious choice. However, we could have taken the first equation and said, like, x is 6 minus y and put that into the second equation had we chosen to do so. All right, the next one is, well, let's take a look. We have x minus 5y is 13. We have 4x minus 3y is 1. So in here, you want to make a choice about which variable to solve for in which equation. Almost always, you want to look for an equation where the number next to the variable where the number next to the variable is a 1. Taking a look up top in the upper left corner, we have just 1x. So that's where I'm going to start. And the reason why is if I solve that equation for x, x will equal 5y plus 13. If we had chosen any of the others, it would work out mathematically. It's just that we'll have fractions involved. Let's say, for example, that I took the second one and solved for x. We'd have 4x is equal to 3y plus 1, so that x is 3/4 y plus 1/4. There's nothing wrong with that. The math is fine. It's just that a lot of times people like to avoid fractions. They find it error prone, and so you may want to make that choice of picking the variable that has a coefficient of 1. Okay, so we'll skip this other one. We've taken our first equation, we'll solve that for x, and we're going to substitute it into the second equation. Be very careful that you don't substitute this equation into itself, right? Because then that's going to give you not what you want, let's say. Okay, so then let's substitute this into the second equation. We have 4x minus 3y is equal to 1. Our x is 5y plus 13. And then distribute to remove parentheses. Combine like terms. Okay, it looks like our y is -3. Once we have y, we'll substitute that back into this equation and find our x. Okay, it looks like our x is -2. So as a pair, we have -2, -3 for our solution. Okay, let's try that again. Okay, so here we have 2x minus 3y is 12, -12y plus 8x is 48. So on this one, there's no clear choice of which one is going to be most great to work with. So it doesn't really matter. I'd probably just pick the one with the smallest number. So the 2x here, I'm going to take that first equation and solve for x. So we'll have 2x is equal to 3y plus 12. And so x is equal to 3/2 y plus 6. Okay, so we're going to substitute that now into the second equation. So we have -12y plus 8x. X is 3/2 y plus 6, and that's equal to 18. Let me double check and make sure I haven't messed up so far. 2x is equal to 3y plus 12. That one's good. And then our x is 3/2 y plus 6. And then we'll replace that in the second equation. Negative 12y plus 8, our x expression, that's 18. No, that was 48. Okay, I knew I'd made a mistake in there somewhere, but it's good now. All right, so now we'll distribute to remove parentheses. We have negative 12y. 8 times 3/2, that's 12y. And then 6 times 8 is 48. Okay, negative 12y plus 12y is 0. We have 0 plus 48 equals 48, and that's always true. So this means that there are infinitely many solutions. Whenever you are going through this procedure and you end up with a situation where the variable's all gone, then and you end up with a statement that is always true, like 48 equals 48 is always true, then that means that one of two things. Either you made a mistake, and I don't think I have, or there are infinitely many solutions. Okay, so that's it. Another way to kind of check that would be to notice that the second equation here is 4 times the first equation in this case. Okay, so let's try this one. The second one, we have the second equation already has y solved for us, so it makes sense to substitute that into our first equation. So 3x plus 2y is 9, and then our y is negative 3/2 x plus 1. This gives us an equation that just has x's in it. 2 times negative 3/2 is negative 3. So the 3x and minus 3x again add to 0. This time we have 0 plus 2 is 9, and so 2 equals 9. And that's never true. So that means that there are no solutions. Okay, this one, there's no point where those two will cross. In hindsight, a way that we could see that would be to take that upper equation and put it in slope-intercept form. We'll have 2y equals negative 3x plus 9, so that y is negative 3/2 x plus 9/2. So now, those two equations, they both have, or two lines, they both have a slope of negative 3/2, so they are parallel, but they have different y-intercepts, so they don't coincide and will never meet. And we saw that, sure enough, there's no solution there. Okay, so that's the basics of how you do substitution. We're going to see a couple of story problems next. Note that we've already seen how to do this using a single variable. Okay, so you don't have to be able to do this. You don't have to do this, let's say, using system of equations. We've already seen how to do this, but you can using system of equations. I want to show you a couple of examples of how that goes. Here it says the sum of two numbers is 10. That will give us one equation. Our two numbers will be x and y. Their sum means we're adding them. We're adding the two numbers and getting 10. Now, one number, I'm going to make the one number be the x. One number is 4 less than another. The another number is going to be the y. So one number is, that's our equals, 4 less than the another number. That's the y. Okay, so this gives us our system of two equations. This one, the equations themselves are not that bad. X is equal to y minus 4. I'm going to take and replace the x in the upper equation and replace it by y minus 4. Okay, so our x is y minus 4. So now we have 2y minus 4 is 10. Sorry, that's a sloppy 10. Okay, and then that means 2y is 14, so that y is 7. Again, once we know y, we can find x. Here, x is 3. So the numbers are 3 and 7. Okay, and that will do it. Let's try another one. This one's about a rectangle. Picture is always a good idea when you're dealing with a rectangle. The perimeter of a rectangle is 40. The length is 4 times as much as the width. So L for length, W for width. The length is 4 times as much as the width. Make a little picture. Okay, there's the length. Guess we should put that on the big side. Length is bigger this time. Okay. All right, and we know the perimeter. Here the picture doesn't help that much. We know that the perimeter is 2 times the length plus 2 times the width. That's our formula for perimeter. And so this is our two equations. We know that the perimeter is going to be 40. So we have L is 4W and 2L plus 2W is 40. Okay, there's our system of equations. Length is 4 times the width, and the perimeter itself is 40. Okay, let's substitute that L equals 4W into the second equation. Hopefully you're finding these to be not too bad. Of course, nothing is as bad as something that's not too bad. All right, so that means our W is 4 and L is 16. So the length is 16, width is 4. Make sure when you're answering this on a test or on like a computer homework system, and you put the answers in the boxes, make sure that you put the right one in the right box. It would be a bummer to get those switched and then it's marked wrong because of that. Okay, so you want to be careful there. Okay, let's try next. The measure of one of the smaller angles in a right triangle is 2 more than 3 times the measure of the other smaller angle. Find the measures of both angles. So this story is about a right triangle. The background information that you need is that a right angle in a right triangle is 90 degrees. And the sum of the angles in a triangle, the sum of all angles, is 180. So that means that the other two angles together, let's call those X and Y, those two together have to make up the other 90, right? Because the whole triangle has 180. If you take away the 90 for the right angle, that leaves you 90 left for X and Y. So I know X plus Y has to equal 90. That's the background information. Now it says the measure of one of the smaller angles, let's say the 1, we'll call that X, is 2 more than 3 times the measure of the other. We'll call Y the other. Okay, so the measure of one of the angles is 2 more than 3 times the other. Okay, let me do that again. The measure of one of the smaller angles is 2 more than 3 times the other. Okay, so there's our system of two equations. And this one, X is solved for us, so it makes sense to drop that into the first equation in place of X. So we'll say 2 plus 3Y plus another Y makes 90. So we'll have 4Y plus 2 is 90. 4Y is 88, and so that Y is 22. Once you know Y, we can get X. We're told that X is 2 plus 3Y. 2 plus 3 times 22. That will be 68. And just to check, what's 68 plus 22? 68 plus 22, it better be 90, and it is. Okay, so those were our two angles. They were a 68-degree angle and a 22-degree angle. Okay, so a couple of story problems. Let's see what else we have. We have like just one more. Okay, this one looks long, but it won't be that difficult. Okay, so it says Mia has job offers from 2 insurance companies. The first company pays a salary of $12,000 plus a $100 commission. That's company 1. I'm just taking some notes. Okay, the second company pays a $20,000 salary plus a $50 commission. Okay, and then for each policy sold. Now, finally, the question part, right? Often in math word problems, the question piece is at the end. How many policies would Mia need to sell to make the total pay for both companies be the same? So the thing that we're looking for is almost always the variable, right? So the X is going to be the number of policies that Mia sells, okay? So taking a look at the way these two things are structured, the first company pays $12,000, but $100 for each policy. So if she's going to sell a lot of policies, she's probably better off with that one because she makes $100 commission on one instead of only $50. But for the second one, the salary is twice or $8,000 more at $20,000, but only $50 for the commission. So if she anticipates making fewer sales, the second one would be the one to go for. But there's some number of policies that she can sell that'll make it where it doesn't make any difference. That is, the extra money she makes in commission for the first job makes up for the fact that her salary is less. Okay, so the total pay that she gets from company one is $12,000 plus $100 for each policy. She's going to sell X policies. The second company, it was $20,000 plus $50 times the number of policies. So we want to know what X will make the total pay the same for both companies. So we're going to set the 12,000 plus 100X equal to the 20,000 plus 50X. Okay, let me subtract the 12,000 from both sides. We'll have 100X is equal to 8,000 plus 50X. Okay, and then subtract 50X from both sides. We'll have 50X is equal to 8,000. And then we'll divide both sides by 50. So we'll have 8,000 divided by 50. So that's 800 divided by 5. And that's 160. Okay, so 160 policies. This one is kind of different seeming because it doesn't look like we had two separate equations for this, just the way that I set it up. We could have had like y be the total pay, right? So we could have looked at it as 12,000 plus 100x is y, and the other one would have been 20,000 plus 50x is y, and y is the total pay. And so immediately we set the y is equal to each other. So it appeared that there wasn't two variables in it in the first place, but that's how it comes out. And that takes us to the end of our work on substitution. We've seen that we could take one equation, solve for one variable, and kind of put it into the other equation. And it's up to us which equation and which variable to solve for. Okay, that takes us to the end of this section. Let me know if you have any questions, and have a great day.